Hello and welcome once again in this MOOC course on control system. And in today's class, we will again study the rules for block diagram reduction. Block diagram reduction. In previous class, we have discussed seven different rules for the same, and these reduction technique is very useful, particularly in case when control system consists of so many stages connected together and to determine the overall transfer function of that complex system. So we have already discussed seven different rules, and in today's class, remaining rules we will cover. So starting from rule number 8. This rule number 8 is related to shifting of a takeoff point. Shifting of a takeoff point. Sorry, shifting of summing point. Shifting of summing point. We will shift the summing point. Summing point is basically junction point where one or two or more inputs can be combined. So it is possible using this block diagram reduction technique to shift the summing point before or after the given block. So in case 1, if summing point is given, suppose this RS is input, summing point, this is the block which is representing one stage with transfer function GS, output is CS, summing point input is RS, and second input to this summing point is XS. So this summing point is at position A. Suppose this is position A and this is position B. So we can shift this summing point from position A to position B. And once again, we will apply the same concept. And concept is that final output is CS should not change in this shifting of summing point. So in this particular case, if we find the output CS, this CS is equal to RS plus minus XS multiplied with forward part transfer function GS. Now this summing point is shifted. So this is block diagram GS transfer with transfer function GS, and position of summing point is moved here. Second input to this is XS. This is plus minus X. This is plus. Reference input is RS. So output, if we evaluate at this point, then output is RS GS. RS. This is RS multiplied with GS. So this will produce at this point RS GS. So this is first input for this summing point. Second input is plus minus XS. So this is plus minus XS. And if we compare this these two outputs, then in first case output is RS GS plus minus XS GS. In second case, this component, this second term is missing GS. In first case, RS GS plus minus, this is plus minus actually, this is plus minus XS GS. Here only XS is appearing and second and term GS is missing. So GS is not present here. GS is not present here. So in order to make this GS available in second term, so it is required that a block should be introduced here, a basic transfer function GS, then output is RSGS plus minus XS GS. So this is the changes. So this is the changes if we shift the summing point from one position to another position, it means we have to introduce a block with transfer function GS, transfer function with transfer function of this additional block GS, in order to maintain the output constant in case 1 and in case 2. So this is the concept of shifting of summing point. Similarly, summing point can also be shifted if suppose there is some summing point at position B, that summing point can also be moved from position B to A. In that case, we will introduce a block with transfer function 1 upon GS in order to maintain the same output. So this is the summing point shifting. This is the rule number 8. Similar to summing point shifting, it is also possible to shift the takeoff point from one position to another position. So this is rule number 9. Rule number 9. In this case, suppose this is the given arrangement. RS is reference input. Summing point is given here. So this is with input XS. Output is CS. Output is CS. This is position A. Suppose this is position A, and we want to, this is the takeoff point, and we want to move this takeoff point at this position B. In this case also same concept will be applied. If we find the output CS, then this output is RS plus minus XS. This output is RS plus minus XS. If output is observed at this point, then it is equal to RS plus minus XS. And in second case, we move this takeoff point from position A to position B. From position B, this is input RS. This is plus, and this input to this block summing point, second input to this summing point is XS. XS could be positive or negative. So here the output is RS. Output is RS in this case. If it is shifted at position B, then output RS should remain constant. At this position, output is RS plus minus XS. There is no change. Now this summing point is shifted here. Summing point is shifted here. So RS in first case is output is RS. In this case, output is RS plus minus XS. RS plus minus XS. RS plus minus XS. It means there is addition of this component. There is addition of this component, which is the violation of the concept that output should not change. Output should strictly remain equal to RS. So in order to eliminate this, we introduce another summing point at this stage. Because we have to eliminate this, we will take opposite sign, minus plus. This input is XS This input is XS. So at this point, input plus minus plus XS will be added here. So this will finally produce the output RS. It means we have introduced an additional summing point, here. Additional summing point is inserted here so as to compensate for additional term plus minus axis. Here sign is reversed, minus plus. So this is plus minus, this is minus plus. So finally we have output which is equal to RS, which was in case before the shifting of takeoff point. So this is moving of takeoff point from position A to position B, which will result in adding new summing point, and input to this summing point will have opposite sign. So in the similar fashion, we can move summing point from position B to position A also. So this is the simple concept of moving summing point and takeoff point before or after from point A to B and B to A. So next rule is rule number 10. This is very useful in order to remove the summing point. In block diagram reduction technique, we try to remove or eliminate the summing point, more number of summing points to transform the overall structure in simplified form. So it is necessary, if it is possible to eliminate the summing point, then problem will be reduced step by step. So how we can remove the summing point? So this is elimination of summing point. Elimination of summing point. We will take some exercise on this block diagram reduction technique, then apply different rules so as to make all these rules very clear to all of you. So this is the elimination of summing point. This is the block diagram with input RS. This is summing point plus this is GS. This is output CS. This is the feedback part transfer function HS. Output of this is BS. This could be positive or negative. As per the requirement, we will take either positive feedback or negative feedback. So this is basically comparator. This will produce the error signal ES. This will compare reference input and input coming from this feedback path. So this ES is error signal. So this error signal ES is equal to RS plus minus BS. At this summing point, one input is RS, so RS is here. Second input is BS with sign plus minus, so this BS is taken here. This is suppose equation number 1. Then out forward part transfer function is GS. So this GS is ratio of output CS to input. Input to this block is ES. So this is equal to GS. This is equation number 2. This output is the result because of this feedback path. That is the this feedback path. So output BS divided by input to this is CS. CS is the input for this feedback path. So this is equal to feedback part transfer function HS. This is equation number 3. So from equation 1, we can, from equation 1, ES is equal to RS plus minus DS. DS is equal to CS into HS from equation number 3. So this is CS and HS. CS and HS. This ES is equal to, this ES is equal to from equation number 2. This ES we can eliminate here. ES is equal to CS upon GS. This is equal to RS plus minus CS HS. And from this relation, this suppose this is equation 4, this is equation 5. From this relation, we can find the ratio of CS upon RS, which is very simple manipulation. So this is CS upon RS, which is termed as overall transfer function, that is equal to GS upon 1 plus GS 1 minus plus GS HS. So this is the final, overall transfer function for this arrangement. So here, if we are taking negative feedback, then it is 1 plus GS HS. If sign is plus, then here we 1 minus GS HS will be taken. So this arrangement can be, this closed loop arrangement can be replaced in this way. RS is input, transfer function is GS 1 minus GS HS, and output is CS. So in this way, this closed loop path, closed loops control system can be replaced by simple open loop system with input RS and output CS and transfer function GS upon 1 minus GS HS. In this way, we can eliminate the summing point. This is very simple to calculate. This is simple manipulation. CS upon RS we have to find. So RS can be taken as common. So this is 1 plus minus RS. In this way we can calculate. So CS upon RS we have to consider. So move this here. So sign will be reversed. So minus, this plus minus will become minus plus. Suppose HS is 1. If HS is 1, then it is the case of unity feedback. Then it is the case of unity feedback. In this case, transfer function CS upon RS is GS upon 1 plus minus plus GS HS. If we are taking unity feedback case, then we have to put HS is equal to 1. So this arrangement is RS. This is summing point plus minus. This is plus minus. Forward part transfer function is GS. This is output CS. And this is unity feedback. So HS is equal to, case of unity feedback, so HS is equal to 1. So in this case, we this HS is substituted as 1. So this is the overall transfer function for this arrangement. We can also find the ratio of ES upon RS in this closed form control system. This RS is given. Summing point is here. This is plus minus. This is second input. Input coming from feedback path. This is forward part transfer function GS. Output is CS. This is HS. This is HS. And we have to find the ratio of ES. ES is error signal, ES. And we have to find the ratio of ES upon RS. We are going to find the relation between ES transfer function, that is equal to ES upon RS. So this ES from this diagram is RS plus minus, this is RS. RS plus minus CS HS. At this summing point, second input is CS is output. This is multiplied by transfer function HS. So this is CS HS. So we can write this input RS. Second input is CS HS, where CS is equal to ES is input for this block and output is CS. So this CS is equal to ES GS. So this ES can be written in this way: RS plus minus ES GS HS. So take RS as common factor. So this ES upon RS is equal to 1 upon 1 plus minus GS HS. So this is another useful relation in order to simplify the block diagram based problem. So we have discussed all the rules for block diagram reduction technique, and in next class we will take some problems based on block diagram reduction. So with this I end this class. Thank you very much. See you in next class. Thanks.